Welcome to Formnext 2023 and welcome to our Expert Insights here on Industry Stage in Hall 11, D72. I'm very happy that you are here with me in the booth and in our live stream. I mentioned earlier there are the possibilities of asking your questions in our Slido tool, and I just received a question from one of you asking where are the recordings of that what we are doing. Yeah, there are recordings, and where they are in the media library of Formnext. After the exhibition you can download or watch every show here on stage. So if you missed the one or the other expert or the other insight, then you can make it at home and then you can watch it afterwards. So, but now continuing on our program, we now want to cover business cases, and business cases is always connected to industry sectors. Different industry sectors say, okay, is additive manufacturing really useful for me, for my certain application? And for example, there is the pharmaceutical industry or medical industry. They have certain needs talking about the quality of the steel, and they say, okay, I cannot work together with additive manufacturing providers because they cannot produce my steel versions and the steel qualities I really need. Our next expert proves that this is not anymore the case. When we are looking for specific stainless steel types, AM offers a variety of materials and different production methods, and two of them are brought to us by Gaetano Mariella. Gaetano, good to have you here.
Thank you.
I learned you have 37 years of experience in the business, and you produced over 20 million pounds sintering material.
Yes.
Is it right?
Exactly right. So in the 37 years, that I've been in the powder metallurgy industry, I started calculating all of the sinter trials and all of the items that we were sintering over the years, and I added it all up, and it's over 20 million pounds.
20 million pounds. How many lorries that are?
Quite a lot. And
Quite a lot.
Most of it is due to the tungsten and refractory metals that I've been sintering over all the years. So yeah, so 20 million pounds. So it's exciting industry. I love powder metallurgy. Certainly on the AM side, there's exciting things going on.
So did I promise too much that we have the real experts here on stage? Gaetano,
right.
I'm very happy that you're with me.
That's why I have no hair, because I've been sintering all this material.
But that's not the same for me, you know. I'm not in that game of sintering.
Exactly.
Metal injection molding and AM binder jetting in the production of 316L industrial parts. That's your topic, and I'm very interested in what you brought with you.
Sure.
The stage is yours.
All right, thank you. Oh, 20 minutes. They took 5 minutes off already. Wow. I'm Guy Mariella, and I'm Chief Technology Officer at PTI Tech. We are a metal injection molding, a polymer injection molding, and AM manufacturing house. So we get involved with high temperature materials, Inconel, titanium, tungsten alloy. On the polymer side, we get involved with engineered polymers, highly glass-filled and carbon fiber-filled high temperature materials. So we see it on both sides, both on sintering side and the molding side. So today I'm going to present to you utilizing metal injection molding and AM binder jetting for a production 316L industrial part. So this is not a theoretical part. This is in current production right now. So you all remember COVID-19, and during COVID-19 everyone was spraying disinfectants to kill the virus. Well, one of the areas that was highly affected was the elevator panels. No one thought that spraying the disinfectants on the elevator panels would cause a problem. Well, these disinfectants actually had an effect where the elevator buttons were actually coming out of the panels. So elevators out of service, very, very costly to the company. So there was an urgent need to come up with a solution for this problem. So this is what we have. The legacy part is a polycarbonate, overmolded, machined stainless steel assembly with the button cap assembled that you can see. So you also can see from this slide, the polycarbonate has this molded flex tab, And this flex tab was used to assemble the button into the electronics in the panel. And you can also see the button cap that you're pushing every day to get to your hotel room. So design considerations. What did we have to do for the client? So the design challenge was to consolidate the button assembly design into a single part, or actually two parts, but eliminate the polymer overmold. So we had to design the flexing tabs in the assembly. This was critical for assembly with the electronics. They had to be flexible enough to be bent by hand for the technicians to install in the elevator without cracking. We also had employed FEA to figure out that what size and what dimensions were necessary to facilitate the bending and flexing. So this was about 30 thousandths thick. Additionally, because the client was in desperate need for a solution, we needed to rapid prototype the designs up front. So we thought that metal injection molding would be a good production path for these two products, the button body and the button cap. And here's the print of the button body. So the button body, approximately 1 3/8" diameter. You can see the tab thickness, about 30 thousandths, and the height of the part, about half an inch in height. This is the button itself, button cap. Again, about 1 inch diameter and about 600 thousandths thick. So because of the disinfectants that were being used, we needed to have some sort of pick an alloy that had a good chemical resistance and was easily sintered, let's say. So we chose 316L stainless steel, and you can see the MPIF 35 standard for this particular material. So it offers good corrosion resistance, right? We needed that for all of these exotic disinfectants that were being used, and it offers good ductility for the product. So the customer was in desperate need to replace the buttons in the elevators. In fact, it's one of these things where we were late before we ever got an order. Customer was desperate for these things. So we needed to come up with a method by which we could design and prototype rapidly in the material that was being used by the customer. So we decided on metal binder jetting because it dovetails well. We thought it dovetailed well with our metal injection molding operations. So part of the advantages of binder jetting, obviously no tooling, which saves on time. Customized part designs can be made in parallel, where we could iterate multiple designs, and obviously the lower cost of the design trials. So after thinking about it, we went ahead and we looked at the metal AM equipment that was out there. So we used a digital metal DMP 2500 using 316L. This is a prior model of the unit that Mark Forge is actually has in their booth today. So with rapid prototyping, binder jetting, we decided to go ahead and take a look at the differences and the alike relationship between MIM and the additive manufacturing world. So binder jetting, linear shrinkage roughly about 20%, MIM somewhere between 14 and 20%. Dimensional accuracy, everyone tells me that they can do a better job, but really when it comes down to it, probably plus or minus 0.5% up to 1.5% without any optimization in the binder jetting. MIM, about 0.3% to 0.5, plus or minus 0.5%. Both processes utilize a fine powder. Both of them require sintering. Residual stress is low in both applications. And XYZ directional properties, well, depending upon who you talk to, obviously the binder jetting folks, they like to say that they're fully isotropic, but we know that they're fairly isotropic. And in the MIM world, we like to say that we're fully isotropic, but maybe we're fairly isotropic, but we're a little bit better in the Z direction, let's say, than some of the binder jetted products are. But again, very, very close in terms of the processing to metal injection molding operations. So, oh, missed one over here. Okay, so this was a slide from Mark Forged. Obviously, this slide gets older and older because the other processes that are on this slide are really catching up in terms of accuracy and in terms of speed to manufacture. But binder jetting still offers a speed and a very, very good resolution on surface finish as compared to some of the other laser-based operations that are out there. So again, surface quality. This slide is getting old, as I say, because I've seen some of, today I saw some of the surface finishes on the laser and EB parts that are really scary. They're getting really fast and really good. So this is a comparison of the laser-based surface finish and the metal binder jetting surface finish. This is just an overview of binder jetting. Obviously, most of you know what these processes are. So, what did we do? So we rapid prototyped the button body and the button cap. We had various iterations of the prototype design that we needed to test. So we prototyped various tab thicknesses and tab cross sections for the flexing. We had tested the sintered dimensional control that we had gotten from the binder jetted product in the 316L. We also had to test the machine surface finish, obviously because this particular part goes into a elevator button panel. You needed to have a good surface finish, so we had to machine it. And we had to be able to final assembly and design the final assembly around the metal binder jetted product. So all of the testing was completed without hard tooling, which is obviously the case in trying to save on time. And time was very, very short. As we like to say, I can't buy back time, right? That's the one thing I can't buy back. I can't buy the time that's gone by. I can't really bring it back. So rapid prototyping was the way in which we decided to shorten and de-risk the design. So finished prototypes were successfully delivered to the customer before any tool steel was cut. So that's the key. We designed the part, and we assembled the part, and we gave it to the customer, and they did their design work prior to us cutting in a metal injection molding tool. And there's one of the parts, which is the button body, and you can see the additive manufacturing binder jetting surface on that particular part. This is the button body. This is the back side, and you can see those flex tabs that have to be actually forced open to make contact with the electrical panel inside of the elevator panel. So how did we do? Well, binder jetting parts, densities were within range of what we would have expected. The dimensional tolerances were fairly good. We had gotten fairly good results from the binder jetted product after sintering, and tab thicknesses were around the 30,000 range that we had talked about. Obviously, there was a lot more iterations that had gone on, but 30 thousandths was about the right thickness for flexing. So there's the binder jetted part before flexing, and then after flexing without cracking by hand. You have to be able to do that in the field, also with a screwdriver or some other tool in order to get it to assemble to the elevator panel. This is one of the areas that we were concerned about, but we had very good results. So we metal binder jetted the product, and then we went ahead and we machined it for surface finish that was acceptable to the customer. Obviously, assembling it into the elevator body, elevator button panel, you want to see nice surface finish for aesthetics. So we were very encouraged that the metal binder jetted parts had a good surface finish after machining. This is a view of the side of the part, and you can see we have also a double start thread that we had machined into the product. Also very good surface finish. Threading was very well, as to be expected. I mean, 316L doesn't machine that great, but it's a little gummy. But this particular product worked well. Oh, the button cap. So this is the cap, obviously, every day going up to the elevator, right? Going up to the elevator, up to your hotel room, pushing the button. Yep. So this is the metal binder jetted product. So how did we do with that? Well, again, densities within range as we would have expected, and dimensions pretty good dimensional control that we had gotten from the binder jetting product. So we were very happy with that. And again, you can see the surface finish of the metal binder jet product. Very good surface finish after machining. So now we have MIM production. So the final design was tested and approved by the customer. We didn't really know what testing was being done behind the scenes, but the customer has a really peculiar test. And the test is a 8-inch diameter steel ball that they drop onto the panel from about 5 feet. And we said, why would you do that? And they said, well, you know, if you're a little drunk and you have broken up with your girlfriend and you're in the elevator and you decide to punch the panel, we want to be sure that you can't break the button assembly. So they were using this specifically for physical abuse. And the binder jetted product actually passed. They were very surprised by that, but it was good that we learned that. And obviously we have robotics that are testing the assembly for 1 million pushes. So all in all, the product survived testing that we really didn't know about. So it was a good surprise. So for MIM production, we went ahead and built multi-cavity MIM tooling, which PTI builds in-house. We build class 101 tools with all hardened tool steel. For MIM, we use hardened D2 steel, 16 points of chromium for wear resistance. For this part, we use novel gating techniques. We also use some novel techniques to eject the part from the metal injection molded cavity. And we use custom sintering setters to make sure that the sinter tabs were staying where we wanted them to stay after sinter or during sinter. So for MIM production, we use modular tooling. The tooling that was produced a near net shape part because there is some machining that had to get done. This was done specifically because what you don't see here, there are multiple iterations and some design changes that have to get done that we use with machining. So we decided to use a near net shape tool to make multiple different iterations of the part to save on time. And again, as I say, final machining was used instead of putting these MIM features into the part. So this is the MIM part. You can see the difference in the surface finish versus the binder jetted product. Again, very, very good surface finish from MIM. This is the button body. You can see the complexity of the metal injection molding operation that we had performed. Some very thin walls, so we really had to come up with some very good gating techniques in order to do this. Mold flow analysis was performed to discover the proper gating sequence, proper gating locations. So how did we do? Well, okay, density, pretty good for 316L. These were sintered in pure hydrogen. Dimensions, pretty good. We came pretty close to nominal. And certainly the tab thickness, we did pretty well from 26 to 30 thousandths. So this tab thickness allowed us to bend without breaking and allow the folks in the field to assemble the product successfully. So again, before flexing, you can see the tabs in this orientation, and then after flexing, you can see where that flexing would occur to get it to stick to the electronics inside and hold the electronics inside of the panel. So again, very good physical strength of the 316L material. And again, this is the MIMmed product after machining. Again, very good surface finish and good surface finish after final machining. So button cap, again, MIMmed button cap, 316L, pretty good surface finish. How did we do? Well, densities were pretty good. And again, our nominal size was okay. We had some small amount of shrinkage, but because we were machining it, it was had more than enough material to clean up. So all in all, we were very happy with the MIM follow-on production for the product. So there you see the button cap machined after it was turned. So very good surface finish for aesthetics for the customer. So here we have AM metal assembly on the left, yeah, and MIM production assembly on the right. So we were able to deliver AM metal binder jetted assemblies to the customer prior to cutting any metal injection molding tools. So very powerful in terms of de-risking the program for the client, saving time, and iterating different designs to get to the point where the client is happy and it functionally works the way we expect it to. So very powerful in terms of time reduction. So the customer was very happy with the ability of getting parts in their hands ahead of time. Yeah, again, side by side, metal AM machined, and then MIM production assemblies machined. So again, very good surface finish. One of the things I was worried about was the surface finish of the binder jetted product, and it all worked out well. So binder jetting worked pretty good. So in conclusion, we use binder jetting as an effective way of dovetailing with our MIM production. In years past, a lot of my colleagues, we've been at loggerheads between MIM and additive manufacturing. But in this particular case, I decided that we would marry the two together and work together to satisfy the client need. So for us as parts producers, that's really what it's about, satisfying the client need and getting them the products that they need for their particular applications. So we use binder jetting successfully to do design for manufacturing testing with the client and process development. So initial time and cost savings were significant. We cut down on that design time. If we didn't have binder jetting, we would have had to redesign tools, reiterate the tools, which become costly. But time was the main concern here. So successful final result was that a cost-effective all stainless steel industrial button assembly was made. It's obviously impervious to the solvents and disinfectants that people are using even today to clean the elevator panels. And the parts mate effectively with the existing electrical componentry which was in the panel. So that was, again, part of the design constraint that we had to make the design fit what was there already, because there wasn't enough time to redesign all of the electronics that were behind it. So a very successful delve into the additive manufacturing and binder jetting. So current state of the program, we've already gone through several other designs with the client, and we have binder jetted successfully a number of other designs, and we are in the process of building MIM production tools for those new designs. So binder jetting together with MIM, we've proven in a real-world example of large volume production that the two technologies can be married together. So this particular design is going to be filtered throughout the world because this idea of corrosion resistance obviously is needed in many different applications, but it will filter into eventually all of the button panels around the world. So very good that we were able to help the client.
You ready? You're finished.
That's it.
Yeah,
Yes.
and I want to applause for. Thank you very much for your insights, Gaetano.
Yes, and I just want to mention, so it's pti.tech. That's our company. We're in Clifton, New Jersey.
Okay. There is a question from our audience coming in via Slido. The question is, have you considered using AM for final series production? Have you done any cost assessment? So it was, my understanding was it was a final production, and it is a series, a small series, right? What you showed us, right?
Well, the initial production was low-rate initial production, let's say 200 to 500 parts.
Yeah.
But the large-scale production, which we're doing using MIM as the primary processing technology, is in the tens of thousands.
Yeah, so it is serious production.
It's series production. And we did consider the binder jetting, but with the current cost, obviously there was a cost that was cost target that the client needed. The metal injection molding was the process that was chosen.
That's the second part of the question. Have you done any cost assessment for this case? You did, but can you share it with us?
Well, we didn't share. I didn't want to go into the cost. I know that always gets asked. But the serial production on the AM design was significantly higher than the metal injection molding operation. Even with large-scale binder jetting machines, the costs were still higher, and we were not able to meet the price point for the client. So MIM was the method by which we did it. But Again, AM binder jetting was used successfully in the prototyping of this product and launched the product for the client in a very time-efficient manner.
Okay, are you here for making contact? Do you have a booth at the exhibition?
We don't have a booth, but obviously our
Where can I find you when I want to have contact and learn more about your
Obviously,
solution?
I'm on LinkedIn, and also pti.tech is the website. But you can find me on LinkedIn. I know a number of folks have reached out to me already.
Okay, and maybe you can stay here at the booth if somebody wants to have a talk to you.
Sure.
Thank you very much, Gaetano.
Okay, thank you.
Thank you for your insights.
Yes.
And an applause for Gaetano. Thank you very much.
Thank you.
Yeah, that was our expert insights here at the stage. Next, we will have the panel discussion in some minutes, so stay tuned and come back.